Hello class, hope you're all well. This is the 6th unit, probably my least favorite unit, but it's part of the curriculum, so we're going to go through it. Make sure that you have finished Unit 4 and Unit 5 before beginning this. This is another one of our small units, but we'll try to get through it as quick as we can. I think it's 3 or 4 lessons. And then we'll move on to the big one, the logs and exponents. That's an important lesson for future math. But let's get into this one. So combining functions. This whole unit is about putting functions together. We're going to put them together by adding them, by subtracting them, by multiplying and dividing. And then we're also going to do what's called a composition of two functions. Okay, well, we're going to combine functions in these 5 methods. All right, first way is to do it graphically. Now, once you get good at this, you're probably going to be able to visualize it, but for now, here's what I do. I'm going to pick some x values, then I'm going to take the f of x values and the g of x values, and then my last column is this. I'm adding f of x plus g of x. Just a couple of things about that. Notice the notation. These two are the same. They're used interchangeably. Okay. The same goes for f minus g of x. That could be written as f of x minus g of x. Same thing goes for multiplication. F times g could be f of x times g of x. And same with division. All right. You might see it like this. F divided by g of x. And that's the same as f of x divided by g of x. Okay, so just get used to the fact that it can show up in several ways, but we'll try to use them all so you've seen them all. So now let's pick a couple x values. You can see there's nothing going on here. There's no sense me picking x as -2. If I picked x as -2, this graph doesn't exist, this graph doesn't exist, so neither does this one. So let's start with the value that we do have, an x value. We have -1, we have 0, maybe 1, and then let's go 2 and 3. We'll stop there because you can see that this is actually important. You can see that at 3, that g of x stops. There's no arrow here. It stops, so I can't pick a value of 4 because g of x doesn't exist there. So I can't combine those two. Okay? So we're going to look in there. So, what is f of x at -1? It's 1. What is g of x at -1? It's -2. If we add f of x plus g of x, you get -1. So this is our new graph. At -1, f of x plus g of x will be -1. Okay, then let's go to 0. Here's f of x. What is f of x at 0? It's 2. What is g of x at 0? It's -2. What's 2 plus -2? It's 0. So this graph would be there. When x is 1, f of x is 3, g of x is -2. f of x plus g of x, when x is 1, would be 1. Okay, then we'll go to 2. f of x at 2 is 3. G of x at 2 is 0. So this would be 3. So there, and then the last one at 3, f of x is 3. G of x is 2. So we get 5. So this graph, if we connect those dots, would go like so. And then like so, and you can see there are no arrows because the graphs end. Okay? That's combining two graphs graphically. Okay? I guess I was supposed to do it down on the next graph. We don't need that graph. It says then state the domain and range of f of x, g of x, and h of x. Well, what is the domain? The domain of f of x was from -1 to infinity. The domain of g of x is from -1 to 3. And so then the domain of h of x, which is what we got when we added those two, would be from -1 to 3. This is important to understand. The domain of the composition function, the combining of these two, is the overlap of the domains. Okay? Let's try another one. So here we're supposed to subtract. So again, another way to write this would be f of x minus g of x. Okay, and then we'll draw the same sort of table. So we'll have x, we'll have f of x, we'll have g of x, and then h of x, which is subtracting f of x, take away g of x. Okay, so where do we start with our x values? Well, if we go 1, 2, 3, 4, 5, 6, 7, this is x is -7. But you can see that g of x doesn't exist there. So if I picked a -7, I can't do this. Okay, same with -6, that's not going to work. So the first value I should pick is where they both exist, right here, -5. And then how far do I go? Well, if I start here, where does the graph, this graph ends here, so the combined graph has to be between there. So I don't need to pick -4, -3, I don't need to do all of them. What I do is I look at significant points. Okay, so for example, let's take the first two. Let's take where they turn, and here where this one turns. So I could pick probably points like that. Okay, so I'm going to pick -5, -2, 0, and 2. What is f of x at -5? 1, 2, 3. We'll say 3.5. Maybe it's 3.6, doesn't matter. I'm not going to be too particular about that. Okay, so then g of x is 6. At -2, looks like f of x, we'll say 1.5, and g of x is still 6. At 0, looks like about 0.5, g of x is 3, and at 2, f of x is -1, g of x is 3. Okay, let's combine those. We're supposed to subtract. So you get -2.5 here, -4.5, -2.5, -2. Sorry, +2. Oh no, wait, I'm subtracting, so it's going to be -1 take away 3, this is -4. Okay, so just make sure you got that. So we're going -1 take away 3, we're going 0.5 take away 3, we're going 1.5 take away 6, etc. Okay, so let's plot those points. At -5, it's going to be 1, 2, 3, 4, 5, 6. No, it's going to be -2.5. Right here. At -2, we're at -4.5. Right there. Then we go at 0 to -2.5. And then at 2, we'll go to -4. Okay. And then after that, it doesn't exist. So let's put this together. We're going to get a graph that looks something like this. Okay, a little bit of a strange one. Okay, again, I didn't do it down here. Usually it's easier to do it on the same graph. Okay, a quick little lesson on the domain. What is the domain of f of x? Domain of f of x was -7 to 2. the domain of g of x was from -5 to infinity, what is h of x? H of x is the overlap, -5 to 2. Okay, again, if you're not sure what I mean by overlap, from here to here. Okay. Now, one with multiplication. All right. Again, I'll make my table. As you get good at this, you might not want to do a table. You might want to do it mentally. It's totally up to you. Okay. Now we're going to look for where the graph overlaps. So from here to, and look at this, to infinity. Okay, so we're going to go from -1, and then we'll pick a few values here to kind of get the pattern. We'll do something like that, see if that gives us enough information. Okay, at -1, f of x is -3. At 0, it's -2. At 1, it's -1, 0, 1, 2. How about g of x? At -1, it looks like about 0.5. Then it goes to 0. Then again 0.5. Then it goes to 2. At 3, it looks like it's 1, 2, 3, 4. It looks like 5. And at 4, 1, 2, 3, 4, 5, 6, 7. We'll say it's 8. And this time h of x is multiplication. Okay, so if we multiply this, you get -1.5, 0, -0.5, 0, 5, and 16. Remember, we're multiplying. Okay, so at -1, -1.5. Then 0, then 0.5, -0.5, then 0 again, then 1, 2, 3, 4, then 5, and then 16. That's going to be like off the charts here. All right, what shape does this make? It's actually kind of a cubic shape, which if you think about it, that should make sense. I mean, this is a graph y equals x minus 1, and if you multiply that by a parabola, you end up with a cubic. All right, keep that in mind. You should always think about what kind of graph you've come up with there. Okay, and very quickly, the domain. What's the domain of f of x? It's -1 to infinity. What's the domain of g of x? It's -infinity to infinity. What's the domain of h of x? The overlap, -1 to infinity. Okay, now we've kind of figured out the pattern here, how to do this. There's a special thing to consider though when you divide, right? When you have quotient, you need to think about the denominator because the denominator can't be 0. What happens when the denominator is 0? Well, we get a vertical asymptote. Okay, so let's try and look at this one. Okay, you can see both of these are going from -infinity to infinity. So even though this arrow seems to stop here, it does keep going. But what we'll do is we'll kind of go from about here to about here and try to figure out the pattern. Okay, and again, we won't take every point. I think it would make sense to take points that are kind of easier to figure out. So I like this one. Like this one. Like this one. Okay, so if you look at that, that's negative 3, 0, and 3. I think it makes sense to take maybe here too, right? So this is going to be at negative 5, and then we'll also do it at positive 5. Okay, so let's see if we can look at those values. Now, I just picked those 5. Really, it doesn't matter which ones you take. I'm taking those for a specific reason. I'm looking to see sort of where I can find points that are nice. Okay, now you could gladly have said, I want to take 4 and taken here and here. That's also a pretty good spot. But I don't know about, say, at negative 2. I don't know if I like this one. Well, that's actually okay too. Could have done that one too. Okay, try to make nice points though. Okay, but x is negative 5. What is f of x? F of x is negative 5. In fact, this is the line y equals x. Okay, then let's do g of x. At negative 5, we get negative 6. At negative 3, you get 0. At 0, you get 1, 2, 3, 4. And then repeats itself. Okay, now g of x is what we're dividing by. So to get this point, we're going negative 5 divided by negative 6. Well, let's just leave it as 5/6. Here you're going negative 3 divided by 0. What happens there? There's a vertical asymptote at x is negative 3. Here's 0 divided by 4, you get 0. 3 divided by 0, vertical asymptote at x is 3. And here you're going to get negative 5/6. Let's see if that's enough to graph it. Okay, so at negative 5 you get 5/6, so that's going to be about here. Then here we're going to have an asymptote. Here we're going to have another asymptote. Here we're going to have 0, and then we're going to go to negative 5/6 for this one. Well, I don't know about you, but that doesn't look like it's enough to draw the graph. I think maybe I would like to have a little bit more information. Let's think about it for a minute. What's happening over here? Well, we're taking f of x divided by g of x. You can see that both f of x and g of x are negative, so all the values will be positive. And we know that what we're doing is a graph where you have x over, and I don't know, this is like something like x squared, negative x squared plus 4. It's something like that. Do you remember how to graph this? Anytime the numerator had a degree less than the denominator, you had a horizontal asymptote at y equals 0. Okay, so we should have this. By the way, I don't know if this is the right graph, x squared plus 4. I'm just kind of guessing. I know it's an upside down parabola, so I don't even need to know what that 4 is. I just know that the horizontal asymptote is y equals 0. So then my graph is going to look something like this. And down here, it's going to look something like this. But what's going on in between here? In between the two asymptotes? Well, here you have one positive, one negative value. Here you have both positive values. So thinking about that, I'm going to have, it's not going to be a parabolic shape. So let's pick a couple more values. Let's take negative 2 and 2. If x is negative 2, f of x was negative 2, g of x was 2. So if we're dividing, you get negative 1. But then over here, you get 2 and 2, and you get positive 1. So this graph will look something like this. Okay, now you do need to know a little bit about graphs to be able to do that. The table of values probably wouldn't be enough. You would have to consider what shapes are you dealing with here. Okay? The key lesson, though, is that when the two functions are combined through division, the new domain is restricted to those values for which the denominator does not equal 0 and where the two functions are defined. So it kind of has an extra condition here. Here we just know that where are the two functions, where are they in common. Here we also have to consider that the denominator can't be 0. Okay, so I'm going to give you just a few questions to try. That's it for today.